Hi guys, let's talk about circumference and area of a circle. This should be something that you're already well acquainted with, but just in case you have forgotten, let's review it because we're going to talk about how to find the arc length of a circle and the area of a sector of a circle. So just a reminder, I'm sure you all remember that the circumference of a circle is the distance around a circle. Remember, we don't call it perimeter because that's the sum of all the sides of a polygon, so we need a different word for that when we talk about a circle. And area is um, the filling in, the units required to fill the space enclosed by a circle. That's really true for almost anything. All right. And remember, we've recently studied circles, so you should hopefully remember that a circle is the set of all points equidistant from a point called the center, right? Okay. So there's two different ways you can talk about the circumference of the circle. You can talk about it in terms of its radius, or you can talk about it in terms of its diameter. So one form is to say that the circumference is equivalent to pi times the diameter, or if you want to talk about it in terms of the radius, remember then the diameter is twice the radius, so the circumference is equal to 2 times pi times the length of the radius, right? So in this case, remember that d is equal for the length of the diameter, and r is equivalent to the radius. And the formula for area of a circle is pi r squared. Okay, still R stands for radius. So it's going to be very easy to confuse circumference and area of a circle, especially if you're going to use the formula for circumference in terms of 2 pi r and area as pi r squared. So how could you maybe recall the difference between those two? So I'll try to give you a couple of tips. In general, I still like to use 2 pi r a lot, but they both have a pi, they both have an r, and they both have a 2. And so the only time that these answers would be exactly the same is when the radius has a length of 2. If the radius has a length of 2, 2 times 2 is the same as 2 squared, but not true for any other number, including not even true for 1. So remember that area is measured in square units. So maybe that's going to help you to recall that it should be r squared for area, but not for circumference, right? Okay, and just remember that diameter is a chord, right? A segment that has endpoints on the circle and that passes through the center of a circle, and a radius is the length from the center to a point on the circle, and it can be a radius segment or a radius length, right? All right, so let's find the circumference of a circle. We're going to find the circumference of a circle in terms of pi, and we're going to do two different problems, and then we're going to round it to the nearest tenth. So in terms of pi is what we would call an exact value. And of course, rounded to the nearest tenth is an approximation, and that's when you're going to use your calculator. And no calculator for the exact value. All right, so circumference has two different formulas, and in the first picture, circle M, we're given the diameter, so it's probably just easiest to say that circumference is equal to pi d, which would be 15 pi. We should write the number in front of pi in general. Inches, circumference is linear units, and that's an exact value, right, in terms of pi. And then if you want to approximate it, then the circumference is approximately, and we're going to round it to the nearest tenth, approximately 47.1 inches. And that would be your rounded value, right? Okay, so you have an exact value and you have a rounded value. Okay, one more time. But now instead of using pi d, I'm going to go ahead and use 2 pi r. Circumference is equal to 2 pi r. So 2 pi times 4, which would give you an exact value of 8 pi centimeters. That would be in terms of pi. And if you wanted to do an approximate, then you would just type in 8 pi on your calculator. Please don't use 3.14. You're no longer in elementary school. So this would be approximately 25.1 centimeters. In general, a lot of times in elementary school, you're told to use 3.14 to approximate. Frequently, that's because some programs don't, and it definitely encourage students not necessarily to use calculators. And so they give you an estimate of 3.14 to use that. But you are, in general, using your calculator. So I would like for you to use pi on your calculator to make an approximation. 3.14 is not an exact, it is an exact value, and that is not, it's just an approximation of pi. It's not actually pi all by itself. All right, let's keep going. We want to find the area of circle K in terms of pi, and the formula for area is pi r squared, area of a circle. And if 16 is the diameter, then the radius must be 8, so 8 squared, and that gives us 64 pi meters squared. Remember, this is square meters for area, and that's an exact value in terms of pi. Okay? All right, for the next one, we're going to find the area of a circle with a diameter length of 26. Be careful not to use that. That means the radius is equal to 13 centimeters. So remember that area is equal to pi r squared, not diameter squared. So pi times 13 squared, which is not 26. Remember, it's not 13 times 2, it's 13 times 13, which is 169 pi centimeters squared for your area, right? Okay. Let's try something a little bit different. We're going to find the circumference of a circle that has an area of 225 pi centimeters squared. So we're looking for the circumference. So I'm going to put that over here. Circumference is what's unknown, right? And we know the area. And area, formula for area is pi r squared, but we know in this case that the area is given as 225 pi centimeters squared. I'm not going to include the units in the problem. Equals pi r squared. Let's get rid of that pi. Pi is a number that we can, in fact, divide by, so that we get 225 equals r squared. Should have done that purple. And then remember that you're going to take the square root of both sides. And this is one that I asked you to memorize. I asked you to memorize perfect squares through 20. So you should know that the square root of 225 is 15. We think we're done, but we're not done. Remember, we're looking for the circumference. So now we're going to come over here and we're going to find the circumference, which is equal to 2 pi r. So that's 2 pi times the 15 that we found from the area formula, right? And that gives us 30 pi centimeters. Remember that circumference is a linear measurement because you are measuring the distance around the circle, as if you were putting a fence around a circular tank or can or something, okay? All right, let's move on. Okay, a wrestling mat's a square with 40-foot sides and a circle 28 feet in diameter is painted on the mat. Wrestling is not allowed outside the circle. Find the part of the mat that is not used for wrestling and approximate your answer to the nearest tenth. Okay, so obviously understanding the problem is best to do first, and in order to do that, it's probably a good idea if we do what? If we draw a picture. You know that I always want you to draw a picture as much as possible. So we're going to draw a picture of a square wrestling mat, and we're going to put a circle on the inside. I'm not really positive how big those circles are supposed to be, so I'm just going to guesstimate and say maybe something like about that. Okay? All right, and what information do we have that we can put in here? We can say we have 40-foot sides. Remember that all the sides of a square are congruent, right? We have a circle that is 28 feet in diameter, so let's go ahead and put in a diameter here. It really doesn't look like I put it in a good place, but we'll see if we can move that a little bit. It's a little bit better, and we'll go ahead and make it look like we're putting a center in there, okay? And we have 28 feet for the diameter, okay? So we want to talk about what is it that's really what we're looking for. We want to know the part of the mat that is not used for wrestling, right? The area of the mat that is not used for wrestling. So let's go ahead and kind of highlight that a little bit. So if you're supposed to say inside the circle for wrestling, then the part of the mat that's not supposed to be used for wrestling is all of this space in here, right? Okay, I know this seems like a complete and utter waste of time, but it's not a bad idea for you to know what space we're talking about there. Okay, so how would we do that? Well, imagine that if you were rolling out a square piece of dough and then maybe using a large round cookie cutter and cutting out the centerpiece, then the yellow shaded region would be what you had left over, right? So we're going to find the area of the square, and we're going to subtract the area of the circle because we're taking that away. That's exactly what we're trying to do. To find the area of the mat not for wrestling, that's what we're going to have to do. We're going to find the area of the square, and we're going to subtract the area of the circle. So area of the square is s squared. Area, formula for area of a circle is pi r squared. What's the side length of your square? That's 40 feet squared minus pi. What's the radius of your circle? If your diameter is 28 feet, then remember that r is equal to 14 feet. So that's 14 squared, right? Okay, and we want to approximate your answer to the nearest tenth. Okay, I know some of you like to work this problem in parts, which is totally okay. There's nothing wrong with that. You may want to go ahead and square the 40 and get 1600 and square the 14 and get 196 pi. But remember that I'm asking you to answer this to the nearest tenth. Okay, so I'm going to go ahead and type into my calculator 1600 minus 196 pi. And the area that I'm going to get that is not for wrestling is 984, approximately 984.2 square feet. Okay, area not used for wrestling. Okay, there we go. That'll do it. All right, let's try something a little more complicated. Let's find the area of the shaded region in this figure. So let's think about what we're talking about. I think it's unclear to you, so I'll just try to identify this. Definitely should be a rectangle. So what are you looking at when you're looking inside this rectangle? Inside this rectangle, we have one complete circle, which is here, right? And then we have a half circle here and a half circle over here. So technically, how many whole circles do we have? We actually have 2 whole circles enclosed in a rectangle, right? So if we want to find the area of the shaded region, which is what we would get if we take the circles out of the rectangle, then we're going to do the area of the rectangle minus the area of 2 circles, right? We have 2 circles. All right, so what's our formula for area of a rectangle? That's base times height minus, and we have 2 circles, 2 times pi r squared. It looks like both of those circles have the exact same radius. All right, so now we got to figure out the circle part. That's not so bad. 2 pi times, we already can see in the picture that the radius of each of those circles is 6, right? So that's not bad. But we don't know the base and the height of the rectangle. So let's see if we can use that radius to figure it out. Notice that if this radius is 6, right, and this radius is 6, and this radius is 6, then that would mean that we could have a radius drawn here, and another radius here, and another radius here, and another radius here, right? Which means that we can take that 6, and we can say this is 6, and this whole diameter then is 12, and this radius is 6, which means the length of our rectangle is 24 units, and our height from top to bottom, if our circle has a radius of 6, then this would be 12 units, right? Okay, so we have 24 and 12, which should be 288. 288 minus, and 36 times 2 is 72 pi. That's an exact answer, and that would be units squared, because I didn't give you a unit of measurement, so you put units and you just don't forget to square the entire thing. There we go. Okay, we're not squaring the number, we're just writing units squared, but that is an exact answer. And as far as that goes, for area and circumference of a circle, that's about it.